The 1980s were a wild time for truck engineering, maybe too wild. Manufacturers pushed boundaries with futuristic electronics, experimental drivetrains, and designs that were supposed to change the world. On paper, these trucks looked unstoppable, but on the road, they broke down, fell apart, and failed harder than anyone expected. Some were too complicated, some were too expensive, and some were simply decades ahead of what drivers actually needed. Get ready, because these are the 10 over-engineered 1980s trucks that crashed and burned in spectacular fashion. Number 1. Ford CL9000 Aeromax. The Ford CL9000 Aeromax was Ford's attempt to leap ahead of the trucking world with an ultra-modern aerodynamic Class 8 truck. In the early 1980s, fuel prices were high, and aerodynamic design seemed like the future. Ford went all in, building the CL9000 with futuristic wind tunnel-shaped panels, rounded fenders, flush glass, and a sleek fiberglass shell designed to cut through the air like no other truck on the highway. On paper, it was brilliant. This was one of the most aerodynamic semi-trucks ever made at the time, but in reality, it became a rolling example of over-engineering gone wrong. First, the fiberglass panels were extremely difficult and expensive to repair. Drivers hated the fragile construction, especially long-haul operators who needed durability above all else. The cab-over design also limited interior space at a time when the industry was shifting toward roomier conventional trucks. But the biggest failure came from Ford's obsession with integrating everything into a sealed aerodynamic shape. The complex wiring, strange component placements, and unusual assembly techniques made repairs and maintenance a nightmare. Truck stops and independent mechanics simply didn't want to deal with it. The Aeromax also arrived at the wrong time. By the late 1980s, fuel prices stabilized, and fleet managers weren't interested in paying extra for a truck that was difficult to service. Ford expected the truck to lead a revolution, but instead, it became a financial burden, contributing to the downfall of Ford's heavy truck division entirely. The CL9000 Aeromax now stands as a perfect example of how futuristic ideas can fail hard when real-world practicality is ignored. Number 2. GMC Astro 95 TurboCruiser III. The GMC Astro 95 TurboCruiser III was born from a time when engineers were obsessed with the idea that turbocharging and computer-based controls would define the next generation of trucking. GMC poured huge resources into developing a fully integrated turbo system with odd ducting layouts, advanced electronics, and multiple sensors, far beyond what the average 1980s mechanic had ever seen. It was supposed to make the Astro cutting edge. Instead, it became another example of over-engineering sinking a once-trusted model. The TurboCruiser III's biggest flaw was that it relied on an early form of electronic engine management that was notoriously unreliable. Sensors failed constantly, wiring corroded, and the truck's onboard diagnostic system was practically useless in the real world. Most mechanics didn't have the tools or the patience to deal with it. The truck spent more time in the shop than on the road, causing many fleet owners to dump them quickly. But the over-engineering didn't stop at the engine. GMC attempted to redesign the Astro interior with a futuristic aircraft-style dashboard filled with lights, indicators, and switches that confused drivers more than it helped them. The driver visibility was reduced by odd pillar design, and the large plastic cabin components cracked easily. The advanced cooling system meant to keep the turbocharged engine at optimal temperature often leaked or failed altogether due to the complicated routing. By the end of the decade, most TurboCruiser III units were scrapped or abandoned. What was supposed to be a cutting-edge experiment turned into a costly disaster. It was proof that technology must evolve gradually, because going too far too fast can destroy even a respected brand. Number 3. Renault AE, the Space Cab prototype. Before Renault launched the legendary AE Magnum in the 1990s, they experimented with a highly advanced Space Cab prototype in the 1980s. This early version was meant to revolutionize trucking with a flat-floor cab, cube-shaped aerodynamics, integrated electronics, and a futuristic living space. However, the prototype was so over-engineered that it never made it to full-scale production, and the versions that were built ended up being mechanical disasters. The truck's biggest flaw was its cab-over-flat-floor design, which required an extremely complex structural setup to maintain rigidity. The mounting points were fragile, the cab flexed under heavy loads, and early crash testing showed concerning weaknesses. Renault engineers attempted to solve the issue with reinforced beams and additional bracing, but this only made the truck heavier, reducing fuel economy and overloading the axles. Inside, the Space Cab was packed with features no other truck offered at that time. A refrigerator, integrated climate zones, advanced lighting controls, and a digital dashboard. Unfortunately, the electronics were far ahead of what 1980s reliability standards could support. Switches failed, dashboards glitched, and wiring harnesses overheated or shorted out under daily use. Another major issue was cooling. Renault tried mounting the engine lower and farther back to improve cabin space, but this complicated the airflow and caused overheating at highway speeds. The truck was also plagued with transmission failures because the new gearbox they engineered for it was not properly tested for long hauls. The concept was brilliant, but the execution was far too early. The Space Cab became a lesson in waiting for technology and manufacturing techniques to catch up. Many ideas from this model eventually evolved into the successful Renault Magnum of the 1990s, but in the 1980s, it simply failed hard. Number 4. Mercedes-Benz NG80 Special Prototypes. Mercedes-Benz has always been known for precision engineering, but during the 1980s, the company developed a series of NG80 experimental prototypes that went too far. These trucks were fitted with a huge list of experimental systems: automated transmissions, electronic braking systems, advanced traction control, self-diagnosing computers, and hydraulic-electric hybrid steering. Mercedes wanted to create the most advanced truck fleet in the world. Instead, their prototypes became known for catastrophic failures. The automated transmission was one of the earliest attempts at clutchless driving for trucks, but the electronics controlling it were extremely unreliable. Trucks would randomly shift, refuse to shift, or get stuck in gear on climbs. Drivers nicknamed them confused robots. The electronic braking system was equally problematic. When sensors failed, which they often did, the brakes defaulted into emergency mode, causing unsafe behavior on the road. Inside the cab, Mercedes packed in far too many experimental switches and screens. Many of these components overheated in summer conditions or malfunctioned in cold weather. The wiring looms were incredibly complex, and even Mercedes service centers struggled to diagnose problems. Outside, the truck's aerodynamics were improved using fiberglass fairings that cracked easily in cold regions. The new headlamp assembly was expensive and difficult to replace. To make matters worse, the new generation engines were packed tightly under the cab, making maintenance extremely difficult. While the NG80 prototypes never made it to mass production, they consumed huge resources and were considered internal failures. Many of the technologies would eventually mature decades later, but in the 1980s, they were simply too unreliable and expensive for real-world use. Number 5. Volvo F12 Electronic Turbo Assist. The Volvo F12 was one of the most respected trucks of its time, known for durability and strength. But when Volvo experimented with the Electronic Turbo Assist (ETA) system in the late 1980s, they created one of the most over-engineered flops in trucking history. The idea sounded promising: an electronic system that monitored turbo pressure, fuel delivery, and airflow to increase power while maintaining fuel efficiency. Unfortunately, it became a disaster. The electronics of the ETA system were extremely sensitive. Moisture, vibration, and temperature changes caused sensors to fail constantly. The wiring harnesses were prone to corrosion, especially in Nordic climates. When the ETA malfunctioned, the truck would lose power, go into limp mode, or simply stop running. Drivers were left stranded on highways, sometimes in freezing conditions. The turbo system itself was complicated, using additional valves, actuators, and computer controls that mechanics were not familiar with. Even Volvo dealerships struggled to keep these trucks running reliably. The repair costs skyrocketed, and many owners retrofitted the trucks back to non-electronic turbo setups. The additional components also added weight, reducing payload capacity and increasing fuel consumption, the opposite of what Volvo promised. Some fleet operators reported that their ETA-equipped F12 trucks spent nearly as much time in the workshop as on the road. What made the failure even more painful was that the standard F12 was an outstanding truck. Volvo took a proven design and drowned it in unnecessary complexity before electronic systems were mature enough to handle such tasks. The ETA project quietly disappeared by the early 1990s, and today these models are rare because most of them were scrapped. Number 6. Iveco Turbostar Experimental 190/48 Tech Pack. The Iveco Turbostar was a legend in Europe, but its experimental tech pack version from the late 1980s became a perfect example of overengineering. Iveco attempted to create a flagship truck loaded with every advanced system they could develop: computer-controlled suspension, electronic fuel delivery, experimental cooling systems, and a new aerodynamic kit. Instead of becoming a masterpiece, it became a maintenance nightmare. The electronic suspension system constantly malfunctioned. Height sensors failed, compressors wore out quickly, and the control module was notoriously unstable. Trucks would lean, bounce, or ride unevenly. Drivers hated the unpredictable handling, especially when carrying heavy loads. The electronic fuel system was another disaster. Iveco tried to push early computer-assisted injection, but the programming was unrefined and the components were fragile. Fuel delivery would fluctuate, causing misfires, poor fuel economy, and even engine stalls. Cooling was a major weakness. Iveco redesigned the airflow system to reduce drag, but the more aerodynamic front end restricted air intake. In hot climates, overheating became almost guaranteed. Some engines cracked under excessive temperature stress. Even the aerodynamic kit caused problems. The new fiberglass fairings cracked easily and were expensive to replace. The headlights were proprietary and difficult to source, and the extra electronics drained the battery system, leaving drivers stranded. While Iveco tried to push innovation, they did so too aggressively. The industry wasn't ready. Mechanics weren't trained, and the components weren't reliable enough. Only a small number of these trucks were produced, and they quickly vanished from fleets. Number 7. Kenworth K100E. Aerodyne experimented. The Kenworth K100E was already a popular cab-over-truck, but in the 1980s, Kenworth decided to experiment with an ultra-advanced Aerodyne version filled with over-the-top engineering. They added complex front-end aerodynamics, redesigned airflow tunnels, experimental ride control systems, and a fuel-saving engine package. The result? A truck that was beautiful on paper but deeply flawed on the road. The new airflow tunnels were supposed to increase cooling efficiency, but they actually caused hotspots around the engine and transmission. Many trucks overheated under heavy load or during long hill climbs. The ride control system used early electronic dampers that failed regularly, causing the cab to bounce or lean dangerously at highway speeds. The aerodynamic front end looked futuristic but caused major maintenance problems. Panels were difficult to remove, and mechanics often had to disassemble large portions of the truck just to reach basic components. In regions with harsh winters, the aerodynamic fairings cracked or detached due to road vibration and salt corrosion. Inside, the cab featured an advanced dashboard layout that was too complicated for many drivers. Switches failed, gauges flickered, and the new wiring harness design was extremely difficult to repair. The K100E Aerodyne experiment quickly gained a reputation for being pretty but problematic. Most fleets avoided the experimental version, sticking with the standard K100 instead. The project quietly disappeared, and the few surviving models today are reminders that even top brands can miscalculate when they combine too many new ideas at once. Number 8. MAN F90 V10 Prototype. MAN wanted to dominate the European horsepower race by creating a massive V10 engine for their F90 trucks in the late 1980s. On paper, it was an engineering marvel: extreme torque, high horsepower, and incredible hauling potential. But the V10 became a mechanical nightmare that failed hard. The engine was simply too heavy for the truck's frame. The front axle was overloaded, leading to premature tire wear, cracked mounting points, and handling issues. Fuel consumption was extremely high, making it impractical for European routes where fuel prices were already expensive. Cooling was another catastrophic design flaw. The massive V10 generated enormous heat, but MAN tried to use the same cooling layout from their smaller engines. Radiators overheated, coolant boiled over, and engines suffered thermal damage. Many drivers reported that the trucks lost power when climbing mountains or during summer heat waves. The complexity of the V10 also meant repairs were extremely expensive. Basic maintenance such as replacing injectors or servicing the turbochargers took much longer and cost far more than conventional MAN engines. Fleet owners quickly realized the V10 was not cost-effective and abandoned the experiment. While MAN hoped to create the most powerful European truck of its time, the extreme engineering resulted in a truck that destroyed its own parts faster than it hauled freight. Today, the F90 V10 is remembered as a bold but flawed experiment. Number 9. DF3600 ATI Advanced Turbo Intercooling. DF's 3600 ATI was meant to be a fuel-efficient powerhouse, using their advanced turbo intercooling system to push performance limits. But in trying to squeeze maximum output from their engines, DF over-engineered the truck into a mechanical headache. The ATI system used a complicated layout of turbochargers, intercoolers, sensors, and fuel controls. This pushed the engine hard, but also produced extreme heat. The cooling system wasn't strong enough to cope, causing overheating during long hauls or hot weather. Some engines cracked or warped under constant thermal stress. The ATI sensors were notoriously unreliable. When a single sensor failed, the engine's power output dropped dramatically or entered limp mode. Drivers lost speed on highways, causing delays and frustration. The wiring harnesses were also prone to failure, especially in humid or snowy regions. DF redesigned the cabin with new plastics and electronic dashboards, but these components aged poorly. Cracks, electrical shorts, and malfunctioning gauges were common complaints. Even the aerodynamic sun visor and fairings caused turbulence that increased cabin noise. While the standard DF 3600 is remembered fondly, the ATI version became one of the most problematic European trucks of the decade. DF learned a painful lesson. Pushing technology too hard without proper testing can ruin an otherwise great truck. Number 10. Mack MH Ultraliner. The Mack MH Ultraliner was supposed to be Mack's leap into the future. A sleek, aerodynamic cabover truck with advanced electronics and modern engineering. But despite its futuristic looks, it became one of the brand's biggest failures of the 1980s. The Ultraliner introduced an all-new wiring system packed tightly inside the cab structure. Unfortunately, heat and vibration caused these wires to rub, short, or crack. Electrical failures became so common that mechanics often spent hours just tracing circuits. The advanced dashboard was filled with early digital gauges, many of which malfunctioned or failed outright. The composite cab panels were lightweight but fragile. Cracks formed around mounting points. Hinges wore out quickly, and the sleek aerodynamic trim pieces snapped off in harsh weather. The panel replacements were expensive, and many weren't available at small service centers. Cooling was another weak point. Mack tried to optimize airflow for aerodynamics, but this resulted in insufficient cooling for heavy load usage. The truck overheated frequently during long mountain climbs, forcing drivers to pull over and wait. Even the air suspension system was over-engineered. It included advanced controls and leveling valves that frequently malfunctioned, causing poor handling or uneven ride height. Fleet owners quickly realized the Ultraliner was too expensive, too fragile, and too complex for real-world trucking. Production remained limited and the model disappeared. These trucks proved that sometimes innovation goes too far. They weren't bad ideas. They were just ideas the world wasn't ready for. Their failures reshaped the industry, forcing engineers to rethink reliability, cost, and practicality. If you enjoyed this deep dive into engineering gone wrong, hit like, subscribe, and tell me which truck shocked you the most. Thanks for watching and stay tuned, because the next video exposes even more machines that pushed the limits and paid the price